In lesson 68, we're going to learn about trigonometric ratios. Fun word. Trigonometry. And what trigonometry is, it's the study of the relationship between sides and angles of triangles. And there are three basic ratios in trigonometry that can be used to find measures in right triangles. So what we're talking about here is, first of all, got to know that we're talking about right triangles. All right, this is what all this refers to. If it's acute or obtuse, this stuff would not work. This is only for right triangles. We have sine, cosine, and tangent. Those are our three functions. And we use an acronym here to help us use our trigonometric ratios. And our acronym is SOHCAHTOA. SOHCAHTOA. Now what that stands for is the S here stands for sine of theta, and I'll go over theta in a second. O stands for opposite, and then there's always a divided sign. H stands for hypotenuse. So our ratio is our trigonometric ratio for sine is sine of theta equals opposite over hypotenuse. So let's say theta was here. Theta refers to an angle. And so so I wrote sine of angle S. Well, theta is our starting point. Since it says angle S, we actually don't need theta because it tells us where we're starting. So sine of angle S equals opposite over hypotenuse. Well, what is my opposite of angle S? My opposite here would be the little letter A. And my hypotenuse is C. The hypotenuse never changes in these ratios. The opposite and adjacent will, but the hypotenuse never changes. But anyways, let's get to cosine, or CAH. CAH stands for cosine of theta. Theta refers to our starting point, equals A is adjacent, that's a new one, over hypotenuse. Now what adjacent means is next to. So if we said cosine of angle S, cosine of angle S would be adjacent. Now here's the deal, there's two adjacent sides, B and C. However, C is our hypotenuse, so by default that makes B our adjacent. So cosine equals adjacent divided by hypotenuse, so B divided by C. And then our last one is TOA, tangent, and that means tangent of theta equals opposite over adjacent. So tangent of angle S, well, opposite of S is A, adjacent to S would be B. So those are your three different trigonometric ratios, and that's for angle S. Well, let's do angle T and see how it changes. So if we're doing sine of angle T, well, sine, okay, look at SOH for so, opposite over hypotenuse. Okay, opposite of angle T is now B, and our hypotenuse is C. And you just continue this trend. Cosine of T is adjacent over hypotenuse. So adjacent is A, hypotenuse is C. And then the last one, tangent, is opposite over adjacent. So tangent of angle T, my opposite is B over my adjacent A. So that was just kind of showing you where things are located. You don't do sine, cosine, and tangent from the right angle. You can't do that. You only do it from the other angles. So that was using little letters. Now let's do some actual trig. Example 3 says find angle, or find side E. It gives us angle 72. So we're going to use, we actually would know what that is by triangle sum theorem, but we're going to ignore that. We're going to use angle 72 to try to find side E. We're going to look at our acronym of SOHCAHTOA, and we're going to see in relation to angle 72, what is the E and what is the 13? Well, in relation to angle 72, E is our opposite. So we know that we're going to have to use one of these that is using opposite. So therefore, since CAH does not use opposite, we can eliminate that one for now. So here's our opposite. Now what does the 13 refer to? Is that my adjacent or hypotenuse? Well, your hypotenuse is always your longest side, and your hypotenuse is always opposite of your right angle. So therefore, I guess my arrows are kind of confusing. Hypotenuse is right here. I was just trying to show you it's opposite of right angle. So therefore, this is my adjacent. So the only one that uses opposite and adjacent is tangent. So we can say tangent of our angle. Previously we said a letter, but we want to try to have an angle here, if possible. So we use tangent of angle 72 equals, because 72 is our starting point, equals opposite E over adjacent 13. Now from this point we're just solving for E. So how do we get E by itself? Well, it's being divided by 13, so we do the opposite and multiply both sides by 13. Now, when you multiply by 13 here, tangent of 72 is its own identity. It's its own function. So we put the 13 in front of it. And now let me show you how you put this in your calculator. First of all, if I type, well, I'll just type in what we see right now. 13, and then tangent is right here under the, or to the left of the caret symbol. There's my tangent button, and you can see cosine and sine by it. So I type in 13 tangent 72, and that equals basically 40. That equals 40. So E equal, I guess it's over here, 40. And it's a side length, so. Notice if I did, however, do tangent 72 equals, it would give me 3 point whatever. And then if I multiplied that by 13, I would also get the same answer. But it is going to be quicker to write just 13 tangent 72. That will be quicker for you. But that is how you put it in your calculator. Now let's look at one more. Example 4 says find x. Okay, let's look at our acronym. SOHCAHTOA. Okay, 32 degrees is what we're given. So what is 8 and x in relation to 32 degrees? Well, 8 is the opposite side. So once again, eliminate cosine. X is opposite of the right angle, so therefore that is our hypotenuse. So we are going to use sine. Sine of 32 degrees, that's our starting point, equals opposite 8 over hypotenuse x. So now we got to get x by itself. Well, this can be a little bit tricky. What we're going to do is start by multiplying by x on both sides. So now I'm left with x times sine of 32 equals 8. X times sine of 32 equals 8. So watch what I do here. Since these are being multiplied, it's x times sine of 32. I can divide sine of 32 on both sides. So now I put in my calculator, I'm just going to read you what I put in, 8 divided by sine 32. That's literally what I put in. And I get 15.1 basically. I'm just going to round it to 15. So x would be 15. But that is your intro to, one nearest hundred, so it would be 10. But that is your introduction to trigonometry. So we're going to continue to use that, and you're going to use that probably the remainder of your math career. So make sure you have this lesson understood.